Hi, everyone. My name is Gunjan Sial. Welcome to the second episode of Journey to MLOps. Again, with me today, I have Raki Rahman. Raki?
Hey, Gunjan. Thanks for having me back. As you know, the last time we talked about essentially demystifying big data and exactly what big data is,
Mhm.
and I think the link should be on your website. So following along with that theme today, what I wanted to do is basically provide a brief walkthrough history against exactly what is Hadoop, what's the big deal about Spark? And I'm sure you might have heard of Databricks at some point, and exactly what does it offer? Just very, very clearly. So essentially, let's go ahead and get started on that.
Yeah, absolutely.
Okay, I'll go ahead and share my screen. Let me know when you're able to see it. Okay, here we go. All right, you're able to see, yeah?
Yes, absolutely.
Okay, awesome. So you know what I'll do? I will bring this on the right so you can actually see our faces too. So from our last engagement, essentially what we talked about is the slides that you're seeing on our screen. Basically, we presented a pretty generic and motivation use case that takes you through a common big data problem that you would face, and then we basically talked about how exactly you can go about doing this divide and conquer strategy in order to go ahead and solve a big data problem.
Hmm.
And essentially, what that was, as I left you off with last time, is the birth of an engine called Hadoop. And essentially, the idea is very simple, right? You've got one computer and you don't want to limit your data processing capabilities as far as the compute and the storage requirements of that computer goes. And so what you
Right.
essentially do is you take your data that's bigger than the computer and you just split it up into manageable pieces. And
Hmm.
then you just have multiple worker nodes go ahead and do the task. And then all you have is kind of like a master node who just basically makes sure everyone's doing their job. You aggregate the result back, you send it off, and everyone's happy. Like that's essentially
Right.
big data. So that's in a nutshell, what I think is like as far as like the pseudocode or the logic for big data goes, that's just essentially it. You just split up the data. Okay, so now that I think we've kind of established what is the fundamental procedure with regards to big data, it's very important that we actually start to appreciate some of the technology pieces, because
Hmm.
it's one thing for me to say, okay, I'm going to take my data and splitting it up and give it to 50 computers, but the second thing is actually the engine that does it.
Right.
Right? Like if you want to go fast, you need to know how to make a car that goes fast, but then you also need an engine that can actually do it, right? You can't have one without the other. So essentially what Hadoop MapReduce is, and I'm going to try to stay as I think generic as possible, not getting into the technical pieces, but what you're seeing on the screen on the right hand side there is essentially a paper that were released by Google in
Hmm.
2003, I believe, was when the paper was released. It's called the Google File System. You can actually search and read it up on it. Essentially, what happened was before the Google file system, there was no way for humanity to basically take multiple computers and
Right.
treat them as one. There was no engine, there was no procedure. Like if you had to, process X amount of data on a computer, you had to do it within the limitations of that computer. You
Hmm.
could never go in and do distributed processing. And so
Right.
when this paper came out in 2003, basically Google built a way for you, a file system, so to speak, GFS or whatnot, that let you take a massive file, partition it in a certain manner, and then basically have that file distributed over like 100,000 computers. And then from a from an overall perspective, that's basically like one file or one data piece, which is like that's incredible, right? Distributed storage.
Right.
Um, and so when that paper came out, I guess the person who found Hadoop, I'm going to tell you about it. But basically, within those 3 years, they took this concept of distributed file that Google had invented, and they basically made this system called Apache Hadoop. And the
Hmm.
logo looks like this. And essentially, like I'm sure you might have heard of a Hadoop at some point. And basically, what Hadoop did was it took this abstract file system and it made an engine called MapReduce. So this
Right.
person, his name is Doug Cutting. He was actually working at Yahoo at the time. So one of the things you might have heard of is, oh, Yahoo invented Hadoop. No, it was a employee at Yahoo
Yeah.
that implemented Hadoop and made it open source. It just turned out that he was an employee there. Anyway, so basically he made this system called Hadoop, and what it was is essentially a coupling of this distributed data system, as well as an engine that you can basically install on multiple computers that would actually let you process. So storage and compute. The storage part was great because it's basically using Google File System, and one of the things
Right.
you're going to find out is this is actually what pretty much every cloud provider in the world is using today, thanks to this technology. But the engine that he had come up with is called MapReduce, and the
Hmm.
reason it's called MapReduce is, if you remember from our previous conversation, if you had a big data file and you split it up, you actually had
Right.
to map each parts of that file to each of the executors or slaves, right? So you would map that, and then basically they would go in and do their own processing within their computers. And then what you had to do is you actually had to reduce the results that they had made, that proverbial CSV file that we talked about with that one line.
Hmm.
You had to reduce that all back, and then you had to aggregate and send it off.
Right.
Okay, so that your boss or whoever, the analytics user, could actually use it. And so this is where I have the kind of color scheme here, talking about like map reduce, and you're doing the data partitioning, you're doing the mapping, sending the partition data back, and then
Hmm.
you're reducing the tiny files back and aggregating and combining the results. So basically this
Right.
is what map reduces in a nutshell. And just a fun fact. So one of the things you might have seen when you like look at Hadoop is this. There's this weird little elephant, and it's just like, what does an elephant have to do with big data? It's actually because Doug Cutting, his son at the time, his baby boy, had a toy elephant called Hadoop. Like, and
Oh,
then he's
that's
like, I'm
cute.
gonna exactly. And so he basically labeled his engine Hadoop because his son loved Hadoop, and so does he. So that's where the elephant comes from, essentially. A lot of people
Nice.
don't know that, but yeah, it's when I first saw it, I'm like, what does the elephant have to do with anything?
Yeah. It
So
reminds me actually of the Disney elephant, right? I'm forgetting its name, but
right, right,
a
right,
popular
right.
one. Yeah.
Exactly. I'm pretty sure that's probably where the toy is, but go figure. Um, right. So with that out of the way, there is something about cloud storage that I want to basically go into. So
Yeah.
one of the things we all use today, throughout the last 10 years, Dropbox became a thing, OneDrive became a thing, iCloud, like
Hmm.
this whole talk about cloud storage became a thing. And it's just like, well, why wasn't this there during like 1990s? And
Right.
it's just like, what actually changed from 1990s till today that allowed for this cloud storage to become a thing? And the answer is the Google file system.
Hmm.
Because when the Google file system was invented, every cloud provider, so your Apple, your Dropbox, whatever, Microsoft, they basically realized they have all of these servers across the world, and
Right.
if they were to implement this Google file system, or what is called today called HDFS, Hadoop Distributed File System, they can now go ahead and offer storage as a service. And all they
Hmm.
have to do is basically make some sort of a, beautiful looking kind of a cloud portal like your iCloud, Dropbox, OneDrive. And then they could just take your and my files and use HDFS to distributedly storage it across the world. And so
Right.
basically that explains, like there's this meme you might have seen which is like, oh, there's no cloud, it's just someone else's computer. And that's exactly what it is. If I wanted, and I bought like 50 computers just in
Right.
my house, I could go ahead and install HDFS on it and have like Racky's cloud, and you could go in and store your files there, for example. So that's all it is, right? It's just that obviously, like, I wouldn't be able to go in and do the kind of SLAs and the kind
Right.
of
To scale
security
it
and
up.
all of that. Exactly. Yeah. Like, I
Yeah.
don't have like 50 employees that are going in and taking care of my data center, right?
Right.
So if power goes out, there goes all my data. So
Right.
that's kind of where like the technology as well as the operations from these companies, the fact that they have this firepower, they're
Hmm.
able to offer this like dirt cheap kind of
Exactly.
storage for us,
Yeah,
right?
and I think economies of scale kick in, right, from that point of view, when
Exactly.
you have a lot of clients all using that same data center.
Exactly. And so you don't have to reinvent the wheel. You just package
Exactly.
it up, offer it as a service, and then off you go, right?
Right.
And so the idea is basically the same, right? When you and I put our photos in OneDrive or whatever, we're basically renting out a tiny portion of Microsoft's massive HDFS cluster, which is why cloud storage is dirt cheap. And the fact of the
Right.
matter is, once the hard drives are actually up and running, like hard drives are, they're pretty much like one of the cheapest things in the world. Like hard
Right.
drives are extremely cheap, and compared to, for example, compute is expensive, hard drives are cheap. And so all Microsoft and these companies have to do is just to make sure that they gather and amass enough of these hard drives, install HDFS with some sort of compute layer, and
Right.
then that's it. Like, they don't have to, like, for me and you to put 1 terabyte of data into the cloud, they don't actually have to do much other than making sure that their
Exactly.
hard drives are running, right? And so it's a really good like business system essentially, like as far as cloud goes.
Hmm.
Okay. So with that out of the way, like it sounds like, a lot of people kind of adopted this MapReduce and Hadoop system, like a lot of banks, a lot of clients that we work with today. And, it's just like, well, we've kind of solved the problem of big data, right? This MapReduce and HDFS thing works. And so going ahead, like why is Spark a thing? And before we understand what the big deal about Spark is, we need to understand what the problems of
Right.
MapReduce is. Okay. And so basically the fundamental problem with MapReduce is the fact that the way the engine was made, you had to persist the data set at each step along the way on the hard disk. So one of the things you
Hmm.
might be familiar with is if you're working on your computer and I go ahead and pull the battery out or the power out, the next time you open up that PowerPoint, there's a loss of data.
Right.
And that's because when you're like running an application on your computer, what's happening is actually it's running on the RAM layer, the random access layer,
Right.
layer, because it's very fast. So like you're seeing my screen right now. It's not persisted on the hard drive. This is actually an application that's stored on the RAM, the data. And so as I'm like scrolling up and down really, really fast, that data is moving really, really fast. And so I'm able to
Hmm.
see it as if it's fluid, but there's no,
Right.
like, this is like this piece of data artifact is something that's on the RAM. So my point is, um, when you're doing MapReduce and you're doing this with data, obviously you need to make sure that as you're doing transformations, they're all persisted along the way. And the fundamental problem is this. Whereas my screen that you're seeing right now, this data is persisted on the RAM. This
Hmm.
means that I'm able to move really, really fast. But if this was coming from the hard drive and I was trying to do this kind of operation, you would see lag every step along the way because the
Right.
CPU would have to go to the hard drive, say, like, okay, this guy just pulled the screen up 2 seconds,
Right.
give me the new data. And
It's like
like
that
that becomes
paging problem, right?
exactly. And
Right.
so like basically hard drives are really good at persisting your data once you actually save something there. Like you're literally like zapping electrons on the hard drive and
Right.
saying, okay, this is what my data looks like. But they're not very good at doing this kind of agile, very fast way of doing things. And the
Hmm.
issue is this: when RAM was invented around like I think it was like 1968 by this individual called Robert Dennard, the way the RAM is fundamentally architected, like the storage layer of the RAM, the reason it's so fast is because persistence is
Hmm.
actually not a required capability coming out of RAM.
Right.
It is of hard drive, but it is not of RAM. The whole point of RAM is, okay, I'm just going to give you all this memory. Just go in and shove as much as you need there. Just cache it all,
Yeah.
just do what you need to, and then don't worry about persisting it, forget it, dump it, and then move on,
Exactly.
right? And so that's what makes RAM so fast. And so if your computer's slow, usually if you go ahead and add in more RAM, that'll allow you to kind of become more agile. So
Right.
with that out of the way, what's the big deal with MapReduce and RAM and hard drive? So the issue is this: hard drives were the only way back in 2003 for us to resiliently store data. And I'm talking about like the computer science of data structure. So essentially when MapReduce was invented by Doug, he could not use the RAM that exists on a computer
Yeah.
to go ahead and do data processing because it wasn't resilient enough. There was no way for him to actually take a data frame, a 20,000 rows of data, and persist it on the RAM layer. That computer science
Right.
technology never existed. RAM was only made for applications. He had to do it on the hard drive. And so what was happening basically is he had all these computers, let's say, and he was going ahead and doing this data operation. At every step along the way in MapReduce, the data had to be saved on the hard drive, and everything you had to do
Hmm.
was on the hard drive. And so if your clusters went down and you didn't have it saved on the hard drive, your data is gone. And so
Right.
basically, the way he wrote his engine is to rely on hard drives. I think you get the point.
Yeah.
And so basically, what happens, right, is when you combine hard disks, which is like there's two types of hard disks. There's mechanical ones, and there's solid state drives. SSDs were very expensive.
Hmm.
To date, they are. Where mechanical ones, which is basically you've got like a disk and it's literally spinning at like 10,000 RPM, and you're using that to read data. So they're fundamentally slow. Hard disks are. And this is basically thanks to the laws of physics, right? If you have a spinning
Yeah.
circle, you can only read data from an optical kind of lens
Right.
only so fast. Like, otherwise if it spins any faster, it's going to like burn out and break or
Yeah.
something. So essentially that's the limiting factor of hard drives. But they're very good at resiliently storing the data. They're very reliable.
Hmm.
So that, and the fact that there's like when you're moving data across these networks, there is actually input-output operations that make the kind of the data computation very costly. And so
Right.
if I'm going from one computer and copying it to another computer, you are relying on kind of the Ethernet capabilities, like the computer to computer. Whereas if you had the data within the same computer, it is able to do things very fast, because that, like,
Right.
there you're talking about like, like subs millisecond, whatever the smallest amount of a computation is. Whereas if I'm taking data from here and moving it to another computer, you're relying on network, which is a
That's
huge
true.
IO overhead. And so essentially, if you were to summarize what is MapReduce, well, it's using slow hard drives and it's relying upon kind of unoptimized IO operations to move data around. And what it is, I'm not going to say MapReduce is horrible, because it's not. It's groundbreaking, but
Yeah.
it's essentially a reliable, good for its time, big data processing engine that did the best it could with the technology it had. So given the computer science limitations of the time at that time, MapReduce is the best you could do, and Doug is a genius for having invented it.
Hmm.
So with that out of the way, note that there's really no, like, there's no proper advantage that MapReduce is using. And we know, like, there's a faster way to access data in a computer and a cluster of computers. It's the RAM. Like, we already know this. This is back from 1968. But the thing is, RAM is, again, as I mentioned, is always used for temporary caching information. So
True.
MapReduce could never leverage RAM. And the
Yeah.
person
So
who
that's
invented
the
RAM,
glass ceiling for it, essentially.
exactly. And the
Yeah.
person who actually invented the RAM never made a computer structure or some sort of a paradigm
Right.
for you to actually store RAM there, because that was not the purpose,
Right.
right? And so the whole point was to be cache quickly, read quickly, and forget about it, right? Okay. So just to kind of nail this point through, let's kind of actually like zoom back a little bit and talk about something that we're actually familiar with, right? So,
Hmm.
for example, I have some numbers here talking about hard drive, solid state drive, and RAM,
Right.
just read write speeds. So if you want to put into perspective like how slow hard drive is, if you remember your laptop or computer from 2001, it would take like 30 to 40 seconds to boot up, like back into the
Hmm.
Windows screen. And the
True.
reason was because you're relying on spinning hard drives, which has very slow read write speeds. Versus today, my laptop, for example, takes 7 seconds to boot up because it's
Hmm.
got a solid state drive and the numbers are about like 5 times faster as far as read goes, right?
Right.
Still not very fast, but it's faster than before. Whereas RAM, the read speed and the write speed of RAM is pretty much like it's 100 times faster than the original architecture from hard drives.
Hmm.
And to put things into perspective, if you ever play video games like on a PS4 or whatnot, it's a very, very dense kind of computation going on in your PS4. Whereas
Exactly.
if you go in and you rotate your joystick to look to the right, you don't actually have to wait. It's instantaneous. And
Hmm.
the reason you're able to get that fluid experience while playing a video game is because all of that information is actually persisted on the RAM of your PS4. And that
Wonderful.
allows for instant response to action. And so the idea is this: if you could do this on a video game, why couldn't I do this on data processing? Right? So if you can imagine proverbial PS4 level kind of
Hmm.
computation when I'm trying to process my data, there's nothing stopping me other than the fact that I've got no way to take data and persist it on a RAM
Exactly. Yeah.
in a persistent manner. And so this is basically what is Apache Spark. So
Hmm.
just very, very quickly, basically what Spark is, the founder of Spark, who his name is Matei Zaharia, he was actually, he went to Waterloo, just down the street from
Oh,
USC.
interesting.
Yeah, so he was doing his PhD at UC Berkeley, and one of the things he was trying to do is solve the Netflix challenge. So one of the things
Hmm.
Netflix, I don't know if they do it to this date, but basically what they would do is they would release this like data set, and it would be something called a sparse matrix. So basically it's a matrix. So I'll give you an example. If there's movies, like there's like a million movies that are available on Netflix, and there's
Right.
a million users that watch Netflix, there's only a certain number of movies that you and I like. So for
Hmm.
example, let's imagine across the columns we've got movies, and then across the rows we've got Raki and Gunjan. You might like a movie which corresponds to a one on like
Right.
one of the movies, and then you might like another movie at the end of that matrix. But
Exactly.
right there, so the thing is, there's a lot of zeros in that matrix because you might recommend one of them but not the other. And
Yeah.
basically when
So
you're
what you're saying is specific genres, but still very, very specific taste towards those
exactly.
genres. Yeah.
Exactly. And so what happens is when Netflix actually captures that data in their system, it's stored in a format called a sparse matrix because there's a
Right.
bunch of zeros. And like basically as far as linear algebra goes, when you're trying to solve for the solution of a sparse matrix like AX equals B, and you're trying to invert that matrix like A inverse, that is a very heavy operation because you've got like a
Amazing. Yeah.
million by million matrix essentially. So my point is, he was trying to solve this pretty difficult problem because he was doing his PhD and there was a Netflix challenge and there was money involved or whatnot.
Hmm.
And from what I understand, he tried to solve this problem using Hadoop MapReduce before he realized that it wasn't the algorithm that he was actually applying that was the bottleneck, but rather the actual MapReduce read write throughput,
Interesting.
right? And so he's like, okay, this is an execution efficiency problem. And so from what I understand, I think with his roommates and whatnot at the time, very very brilliant people, they invented something called an RDD. It's called the
Hmm.
Resilient Distributed Dataset. And basically what it was is Mate and his team had found a way to take that sparse matrix and store it on the RAM.
Right.
And the way they were able to do it is basically like it's like binary level computations on the computer layer. This is basically him having invented a new computer science paradigm. This is not a software. This is not like this is literally something new, right? The
Hmm.
RDD. And so what he did was he did his I think his PhD dissertation where he released this paper where he talked about, okay, we've invented something called the RDD. We can now go ahead and do data processing on the RAM layer without you worrying about you losing your data. It's resilient. Basically,
Right.
whatever hard drives could do, we can now do that with the RDD on the RAM layer. And so basically, this was groundbreaking, right?
Hmm.
Absolutely incredible, and I would highly recommend going in and checking out this
Yeah.
paper. But so essentially after that, right, like you've invented the RDD, that's great. Then Mate and his team basically made an engine called Apache Spark. And
Right.
the reason it's called Spark is because lightning and lightning is fast. And so Spark was using the RDD on the RAM layer to compute data. And basically what happened is this new engine that they invented thanks to the RDD was 100 times faster than Hadoop's MapReduce. Just
Wow.
because RAM is 100 times faster, like this is just laws of physics. Today, there are over 1,450 open source contributors as far as Spark goes. So, for example, Spark is not a licensed engine.
Right.
All the source code that runs Spark is all available on GitHub,
Right.
and you and I can literally go in, clone it. We can make updates and make Spark better, and then contribute it back. And
Exactly.
there's basically like there's a million people across the world that are using Spark day to day today because it's so fast and so
Hmm.
efficient, and there's it's the most adopted big data open source project today. There's nothing else that compares, right? It's literally, this is as fast as it goes. It's on the Rambler.
Right.
And so what's happened is from 2014, Spark has become widely adopted in the industry as the fastest way to process data. And so one of the things you'll notice is, this is really interesting, that one of the only things that I've found to be in common between the three big cloud platforms, which is Microsoft Azure, you've got your AWS, and you've got your GCP, Google Cloud Platform,
Yeah.
is all of their data processing services that they offer for you, they all use Spark. They
Right.
all use Spark. It's not like they're using their own engine. No, when they realize how amazing Spark is and how efficient it is, they're like, okay, forget all our old engines. This doesn't make any sense. Let's
Yeah.
download open source Spark and then give our own flavor to it, and then we'll offer up different services. But under the
Right.
hood, it's all running the same thing, right?
So it's the
It's like,
same technology enabling all three. They're essentially selling economies of scale and the operations capabilities that their companies have, right, to
you
grow that
got it.
product.
Exactly. And
Right.
so you can think of it as like how Ford and Kia and Toyota, they all use the combustion engine, except they
Exactly.
might have made their own. Without someone having invented the combustion engine, there would be no
Right.
Toyota because you don't have the RDD, so to speak. Okay. So with that out of the way, I want to kind of nail in why this is a big deal. Okay.
Hmm.
So you might hear people talking about like, oh, quantum computer is going to come and change the world, and we're going to like, I don't know, like start predicting the future and stuff. And I think like let's calm down a little bit and talk about realistically like what's going on here, right? Okay. So Spark isn't going anywhere soon, and let me explain to you why.
Hmm.
So basically, the concept is very simple. The RAM is the fastest way for you to perform data operations on a modern computer architecture that runs on the world today. So the computers
Hmm.
that you and I are using, our cell phones, my gaming desktop over here, they're all using a motherboard, a CPU, a
Right.
hard drive, and some RAM, right? Even as wee little Raspberry Pi that you can pick up for $20, that's still using these four things, okay?
Hmm.
This is an indisputable truth. So if someone tells you I've found a faster way to process data than you can do on the RAM layer, they're lying. I would love to see like what that new computer chip is, because that doesn't
Right.
exist, right? The second thing is, because the Sparks engine runs on the RAM as the RDD, you can't really go about and making it any better. Like they're already doing it. If something's happening with Spark that's slow on the RAM layer, you can
Hmm.
best bet that the Spark contributors, they're writing up a better way to go about and persisting that data. So you can't
Right.
really have, computer XYZ from certain country or wherever come in and be like, oh, we found a better way to process data on RAM. No, because Spark is already doing that. Like there's
True.
nothing new that you're kind of inventing. And so given these two kind of facts, Spark is literally the fastest possible way to analyze data. Like this
Right.
just makes common sense, right? And so you might have heard about, okay, like, okay, so quantum computers are like, they don't use the binary 0 1 system,
Hmm.
and they kind of store data on a spectrum. And so, like hypothetically, and we've also proven it out, that
Yeah.
quantum computers are a faster way to process data. And I would agree, because fundamentally speaking, when you're not limited to 2 bytes, 0 and 1, and you've got like a whole spread, like across a wavelength of storing data, that is fundamentally fast, because you have like within a given amount of space. That's what quantum is, right? It's you're basically storing data on a very small layer
Right.
given a little amount of information. And so yes, I agree, quantum is a much superior way to store data. Here's the issue. Across the last 50 years, humanity has become really, really, really good at manufacturing binary computers. So
Hmm.
whereas manufacturing a computer 50 years ago, like for example, my Dell, if it existed 50 years ago, it would cost like $2 trillion probably.
Right.
Whereas today, it's probably like $2,000. A
Yeah.
Raspberry Pi is $20 today, not because we've done XYZ, is because operationally we found a very easy way to source the raw material, turn that into a computer chip, and ship it off over to you.
Yes.
That's what makes it so cheap. So my point is, quantum computers, like, good luck with competing with 50 years in the making as far as binary computers go. Like I would love to see a quantum computer becoming like $20, or like a quantum laptop becoming $2,000. No, a
Right.
quantum computer's cost probably like 2 million to $20 million, because there's no streamlined process for you in the world. There's no demand.
Yeah.
There's not a streamlined process. The people who actually do the raw material manufacturing, that's not a thing, right?
Yeah.
And so
I
my
think the
point is,
supply chain and, as you said, the market for it doesn't really exist because people
no, it
don't
doesn't.
know
Exactly.
what
People
to use
don't know
it.
we're using 50 years worth of binary computers. Like, how
Right.
are you going to go and introduce quantum computers and compete? Like, it doesn't make any sense. You need to first find a very cheap way to manufacture it. So, like, an average Joe like myself can go and buy a quantum
Right.
computer. But that's not a technology problem. That is an operations problem. And like,
Yeah.
if we're having trouble like manufacturing masks and whatnot, like,
Yeah.
go figure with quantum computers, right? Like, it's a pretty like transparent conversation at that.
True. True.
And so, just very realistically, if you were to run the same ETL job that we talked about with your in our previous episode, and you try to do that on a quantum computer, sure, it
Hmm.
might take a millisecond, but it's going to take you a few $1 million to actually run it,
Right.
because the computers are expensive. And so
That's when the value goes out the window.
exactly, it's like, really, do I need to wait 1 millisecond, or am I okay to wait like 10 seconds with Spark? Well, I'll wait 10 seconds. My time's not that valuable, right?
Right.
And so basically, this article that I've linked on the right talks about exactly what I just explained.
Hmm.
The return on investment as far as quantum computers goes is not realistic on a day-to-day operations, because we haven't, as humanity, gone about and figured out the supply chain demand, whatever
Right.
that procedure is. And so my point is, quantum computer can go ahead and dethrone Spark's execution capabilities
Hmm.
once we figure out the logistical issues. My point is, don't hold your breath, right?
Right.
And so that's what kind of makes Spark the de facto big data processing engine as far as modern computer
Hmm.
binary paradigms goes, right?
And when you say that, you mean for the foreseeable future as well.
Yeah, like,
Yeah.
the day that I hear that, okay, Raki, you can go out down to like Best Buy and pick up a quantum computer for $2,000. That's the day I'm be like, okay,
Yeah.
someone needs to. So here's the thing: once quantum computers becomes affordable, the next thing that needs to happen is someone actually needs to take what Spark is doing and make an engine on quantum. Because right
Hmm.
now, quantum computers are just, it's a computer. Someone
Yeah.
needs to actually go in, someone that's brilliant on data processing, and make that engine, make it open source. All of the things that happen with a modern computer and Spark needs to happen on quantum computers and whatever that new
Right.
engine is. You can't do that if you haven't found a way to distribute out quantum computers across the world to all the
Yeah.
brilliant like open source developers.
So I know this is taking a little bit of a segue, but one thing that I've been wondering is, do you think that quantum computing could be offered as a service as opposed to a product that you can go and buy in a store?
It can, and there are companies that are doing it, but they're going to cost you an arm and a leg.
True.
Because here's the thing, because like the fundamental fact about innovation is you can never rely upon an organization's capability to deliver innovation.
Mm-hmm.
If I am, and I love Microsoft, but I'm just going to be honest with you. If I'm
Yeah.
depending upon Microsoft developers to go in and figure out how to solve the world's biggest problems, I am depending upon their kind of organization structure to do
True.
innovation. Whereas if I take a problem and I make it so accessible that the entire, billions of people in humanity can solve that problem together,
That's
that
fair.
is the definition of our open source.
So
And
it's an
so
accessibility issue. If the more accessible you make an algorithm or a product,
exactly,
the more
exactly. The more
innovation,
innovations you're going to come out of
right?
it,
More
right?
collaboration,
Exactly. And so you can't just be like, no, quantum is mine. I'm going to do an
right?
offer of service. Like, who's going to use it? Like, are you going to come up with all the training materials and all the use cases and all the different problems that people across the world face and somehow make a website that solves it all? No, you're not. Like, that's not, you don't have like the
Right.
2 trillion employees you need to solve that problem, right?
That's
And
fair.
so
Good point.
that's kind of what that is. Yeah. So with that out of the way, I think let's talk about actually. Okay, so Spark is great. We've established that Spark is the fastest way to do things, and you
Hmm.
can't really compete with that. How does your and my organization actually go about implementing Spark on a real life day-to-day benefit? How can
Yeah.
I actually use it, right? And so that's when the conversation becomes less about okay, Spark is amazing, and more about how can I, as XYZ bank, go ahead and use Spark. And so the
Right.
questions I would ask is, for example, do you have enough servers in your data center, XYZ Bank, to run big data workloads with Spark? And you can actually scale up and down when you need to, so that when you're doing processing, you pay X dollars, and when you're not, you pay $0. Do you have that capability? And more often than not, the banks are like, no, I don't. Okay.
Hmm. Hmm.
Next one, if you remember a resource negotiator from our call last time, which is
Yeah.
like you need to have an engine that can actually go in and negotiate the resources, do the workloads. I would ask that bank, okay, do you actually have that kind of engine in place that can do that robust mechanism? And they're like, no, I don't. Do you have managed clusters that have, like Spark is continuously getting updated? There's new versions
Hmm.
coming out
Hmm.
every other week or whatnot. Do you have kind of a managed mechanism to go in and update all of the dependencies and the drivers and make sure
Exactly.
all the DevOps flow? No, I don't. Okay. Do you have a great visual interface so that the data engineer that you hire straight out of school can actually go in and start using Spark? So it's not too much for them. They're not seeing all these like black and white kind of like mainframe like architecture, but it's
Right.
like an easy approachable interface. Have you built that out, Bank? No, I don't. I don't know how to do that. Okay. Is there secured integration between all your other systems and this Spark cluster that you're going to deploy from this open source by yourself? Do you have that in place? No, I don't. I need to implement it. And
Hmm.
finally, are you able to keep up to date with the industry as it evolves while your business is about like financial services or whatnot? Can you make sure you can compete with all these other providers? No, I can't. Okay.
Right.
So the fact of the matter is Spark is open source, and that's amazing because it's so amazing at processing your data. But you as an individual, it's the same thing about the cloud, right? Like if you're trying to reinvent the wheel and make your own cloud, you're not going to be able to do it.
Right.
You need to go to the people, the industry experts, the subject matter experts that have done this, that are doing this. This is literally their full-time job.
Hmm.
Rely on the kind of innovation that came out of Spark, but don't try to reinvent the wheel yourself as far as managing Spark goes. And so this is where you have the most amazing engine, which has the ability to efficiently distribute jobs and execute tasks on the RAM layer. It's as fast as it's going to get. You've got the platform, which in this case
Right.
is Azure, but for example, AWS also has an
Right.
offering of Databricks that I'm going to get to. So you have the ability to do scalable RAM processing, management overhead. You let Microsoft take care of that.
Hmm.
When you combine these two, what you get is the solution, which is Azure Databricks. So basically, the person who founded Spark, Matei Zaharia, in 2009, he actually invented a company called Azure or Databricks. He's basically
Right.
the CTO. And so this individual, he realized, okay, Spark is awesome. I've made it. It's open source. But when you actually take Spark and you try to implement it
Hmm.
to a
Hmm.
company, there's a gap there. And so let
Right.
me make, because I invented Spark, I know exactly how it works. I'm going to make an offering called Databricks that is literally this engine, which is offered on a cloud platform. So average Joes like you and me can go in
Yeah.
and implement it. And so that's essentially what a Databricks is in a nutshell. And that's actually Matei.
Hmm.
He's a professor of computer science at Stanford University. So like he's pretty smart, so to speak. And he's the founder of Apache Spark. He's the founder of Databricks. He's the founder of Delta Lake and MLflow, which are two things that are going to be very relevant for our
Right.
MLOps conversation. But I'm not going to get into that. But essentially, when you combine the engine, which has unbeatable performance and open source transparency, it is the best big data processing engine.
Mm-hmm.
You then combine the solution, which is allows for cloud scalability. And the secret sauce of Databricks is basically is three things. There's something called the Catalyst Optimizer. So when you give Spark a job, sometimes it's not, if you don't write Spark the correct way, if you're not like super competent with how
Yeah,
Spark works, you can become super inefficient with regards to how you do the data processing. And
right,
so Databricks has built something called this optimizer that can go ahead with Spark to be able to just kind of make everything much faster.
right,
You don't have to worry about the resource negotiation, and that interface that I talked about is all abstracted. You just go in and write your code and let Databricks work with Spark, because that's what they
right.
do. And so that becomes basically the best platform to implement Spark.
So if I understand correctly, the secret sauce there is the configuration settings that the user can provide to make it more user friendly as opposed to having to write that code yourself.
Exactly, because the
Right,
thing is, when you like right now, you can actually go to Google and then you can download Spark on your laptop and
right.
start using Spark. You need to like when you start giving it big data workloads, even though Spark is fast, you need to still know how to give it the configuration and the parameters and the tuning. And if you're
Mm-hmm.
starting out today, it's going to take you like a year to figure that out.
Right,
Whereas Databricks has taken that knowledge and offers that as a managed service. So all you do is just write your code and you let their engine handle it. You're still
right.
using Spark, so it's not like you're in a vendor lock-in, or so to speak. You can
True.
still pull out that code and run it on your laptop, but their domain expertise, they basically, I guess, coupled that up into a service, and they're offering out to you and me.
Great.
That's essentially what Databricks is. Um, so yeah, I think that basically covers as far as like Hadoop
Mm-hmm.
and Spark goes. And I just wanted to quickly give you kind of a sneak peek into our next episode. So what you're seeing here is basically like an MLOps enabled architecture, and this is all well and good as far as big data goes. But okay, what about machine learning? How can I
Right.
use this Spark and whatnot to go in and do machine learning? Well, as you're going to find out in our next episode, this is kind of the kind of architecture that you'd want to have.
Wonderful. Well, thank you so much, Rocky. I really, really liked the way that you told the story from start to finish. And you pointed out who the key players were that added value, how they added value, what were the challenges and the risks with each approach. And we segued a little bit into the quantum computing discussion there, which I'm looking forward to have that side conversation with you as well. So this was wonderful, and I'm definitely looking forward to the last episode there.
Awesome.
So thank you so much. I really
Thanks,
appreciate
Gunjan.
your time, and I hope everybody else enjoys this as well.
All right. Take care.
Take care, stay
Thank
safe. Bye.
you.